All right. So in the last session, we spoke about a point-to-set VPN. What is a point-to-set VPN? How we connect? How do we configure a point-to-set VPN? We were able to completely, successfully implement the point-to-set VPN, and we didn't see any failures as well, which was really good. And a couple of questions raised based on the point-to-set VPN. Discussion. So the question is like, do we need to create these root certificate and client certificate every time we want to install, we want a new client to connect? So the answer is, we don't need to follow the same process every time. If you are connecting to the same virtual network gateway, um, once you create a root certificate and client certificate in the one system, and the root certificate key will be updated in the virtual network gateway, and the client certificate has to be copied into the all the systems where they need to connect to the same virtual network. You don't need to recreate the certificates and re-upload it and recreate the gateway. It's a one-time activity. Okay, that's about the installing or configuring client certificate in each and every system. And the another question is like how often we use point-to-set VPN in the enterprise environment. To be honest, I've not seen many use cases or many customers implementing this solution, because they are already on an enterprise environment, could be in another cloud environment, or could be in the private cloud or on premises. They know, they are familiar with their own tools, VPN tools. They try to prefer to go for such tools. And so very rare customers, like hardly I see like 5 to 10 customers in my experience who uses the point-to-set VPN. But it's pretty cool feature where you only see more cost towards the VPN gateway, not more than that. Okay, and the another question what I've got is, do we use self-signed certificate or enterprise certificates in the enterprise cloud environment? So it's quite obvious. We always go with the enterprise certificate solutions and not the self-signed certificate solutions. It's again, if you want to save the cost, you can just go with the self-signed certificate method. And for POCs and for testing, so we can always go for the self-signed certificate method. All right. So just to summarize what we have learned in the last session, so we had Azure environment where we have virtual machines hosted, and they're part of a subnet and a VNet, right? And what we have done is we configured the point-to-set VPN, and we were able to connect to this virtual machines using the private IP address. So we had a gateway here. Using the gateway, we were able to connect. All right, so let's put the values here to have some good understanding. This is the VPN gateway, which we had set up. And this is the user PC or computer. And this is my production VNet. And this was the subnet, application subnet, and this application VM. And after we set up or establish VPN from my user PC to VPN gateway or a virtual network, we were able to connect to the virtual machine using their private IP address. So we set up using the SSTP, Secure Socket Tunneling Protocol. This is the tunnel type we have chosen. We had other options as well with respect to the VPN tunnel. It's only a business requirement, which one is better for your organization. So what we try to learn now is we will try to understand, if you have another virtual machine, okay, in a different virtual network and different subnet, right? How do you connect these two virtual machines? Let's say this is again a prod VNet. Probably, let's say this is a dev VNet example, right? Dev VNet, and you have one database server, or let's say this is going to be a DB subnet, and this is going to be a DB server. Sometimes you might have your DB server as well here. Let's say you have another server. Let's say this is your DB server, and you might have to do some DB refresh from dev to production, or QA to production, probably dev to QA, QA to dev. So though they are in Azure, let's say they are in the same location. This is the cloud environment. They are in the same location. Let's say this is your east to west location, and they are in the same subscription as well, right? They are in the same location, they are in the same subscription, but they are two different networks. Though they are in the same environment, they cannot connect to each other because the network configuration is different, right? This could be 10 dot series, this could be 172 series, or it could be any other address range. So if you want to establish a connectivity between these two, in the earlier days, what we used to configure is, we used to configure a VNet gateway here and VNet gateway here, and just connect these two gateways. So here with this configuration, you have to provision these gateways. Usually the gateways takes a lot of time to provision. That's another disadvantage. And another challenge what we used to see is the cost for the VPN gateway is too high. So so it's really little bit of a difficulty to set up this and manage this. So with the another solution which Microsoft introduced, we will be able to put let's first to set up the communication between these two. So that is nothing but the VNet pairing solution, a global pairing solution. So using the this global VNet pairing solution, we will be able to establish this connectivity from these two virtual networks with a less time. So you just need to go to the virtual network and enable pairing between these two virtual network, which will eventually establish a connection between these two VNets. So this is one scenario, and it's pretty straightforward and easy to do implement it. We'll try to create another VNet and another virtual machine, and we'll try to establish a pairing between the existing virtual machines what we have it. So there could be other scenarios. You might have another virtual network here in the cloud environment. If you want to establish a connectivity, let's say this is another VNet, and you have a subnet here, and you have a virtual machine here, right? In case if you want to connect to this virtual machine, right, in a different VNet, you can establish a pairing between these two, okay? But in case if you want to establish a pairing, if you want some gateways to route the traffic or propagate the traffic, then you can also establish a pairing between your gateway. So it's like a hub and spoke model. You can just treat this your production VNet, which we have as a hub, and the remaining virtual networks as a spoke. So here you don't need to establish a pairing between the multiple VNets. You might have another VNet in future, and if you want to establish a connectivity to that VNet, you have to create a pairing here. Likewise, you have to keep on creating the pairings between each and every VNet that you are introducing in your environment. To avoid that, what we generally do is we try to establish a hub and spoke model. So we'll create this VNet, and we will enable the VPN gateway. The virtual network gateway act as it will try to forward the traffic to the target virtual network when this virtual net machine is trying to connect to the target virtual network. So here each and every VNet, they try to establish a peering to your hub VNet, not to the spoke VNets. So with this, you are going to reduce the number of peerings for your spokes. So you are only connecting to the one centralized hub VNet. All right. So what we will do is we'll try to set up the two VNets, and we'll try to have a connectivity from VNet 1 to VNet 3 and VNet 3 to VNet 1. Okay, and how this communication is going to happen is, so whenever this VM need to talk to the VM which is in VNet 3, so the traffic will be routed to the virtual network gateway, which is associated with this production VNet, which we are calling as a hub VNet. And from here, it will route the traffic to your VNet 3 VM. So this is how it's going to happen. And to route the traffic to your virtual network gateway, we are going to create a route table, and we will create two routes, one route table here and one route table here. So in the route table here, what we are going to specify is, so if your VNet 1 need to talk to this VNet 3, so we are going to specify for if any request coming to VNet 3, that goes to VPN Gateway, and VPN Gateway will route the traffic to this. So same way, if VNet 3 VM need to talk to the VNet 1, and that request will go back to the VPN Gateway, and that will in turn route the traffic to this VNet 1 VM. So this how it's going to be communicating. We are going to establish the peering, and we are going to establish the routing between these virtual networks. Okay, and let's go ahead and do that. So if I go back to the virtual machine, this is my application server, which is in the production VNet, which we are going to treat this VNet as the hub VNet. Otherwise, what we can do is let's go ahead and clean up this, and let us set up everything from the beginning. Okay, I will go ahead and delete this entire resource group. And we'll let us set up the environment properly. So first of all, let's create a virtual machine, and let's put the right values so that we'll understand. Or let's create a virtual network first. Click on create a virtual network, and provide the new resource group name. Let's say this is going to be the hub RG, hub resource group, and this is going to be your hub VNet. Okay, we can keep this in any location. Let's go ahead and create it in a West Europe location. And we'll go ahead and create this one. Okay, our hub virtual network is created. Let's go ahead and create the virtual network gateway first. Click on create. And I'm going to say this is hub gateway. And we'll go with the same options. I'm going to integrate this with the hub VNet. I'm going with the default options here. It's a route-based VPN. And we'll create a public IP address. And create this one. Yeah, virtual network gateway creation may take some time. It may take up to 15-20 minutes. So let it run. The deployment is in progress. We'll go ahead and set up the another environment. So let us summarize these values first. So what I'm going to do is I'm setting up this environment just to give everybody clarity. So this is going to be our hub VNet, and definitely you will have a subnet here. You can also start deploying the virtual machines here. And this hub VNet will also have the virtual network gateway, and we are saying hub gateway. So same time we are going to have virtual networks in different location. This is another VNet. We say VNet 1 or spoke VNet. Let's say this is the spoke VNet 1, and the other one is the spoke VNet 2. Okay, and here we will deploy the spoke VM1, and here we'll also deploy the spoke VM2. This is a virtual machine 1 and virtual machine 2. Let us say this is the spoke VM1, and this is going to be spoke VM2, right? So what we are going to do is we are going to establish a peering between these two virtual networks and these two virtual networks. Okay, this is like hub 2, spoke 1, and hub to spoke to, right? Or we can say reverse as well. So then what we are going to do is we are going to create a route table here. And let us say this is going to be spoke spoke table 2. And let's say this is the 1. Okay, we're going to create 2 route tables here and associate these route tables in to these subnets. Okay, associate them. And here what I'm going to create is I'm going to create the routes. Okay, how the routes looks like, they should be configured as, let's say, any traffic. Okay, any traffic reaching to spoke VNet 1, okay, should be routed to the VNet gateway. Okay, we are going to specify this condition in the route table or in this route. All right, so when the spoke VM2 is trying to connect to the spoke VM1, so this route will be learned and it will route the traffic to this virtual network gateway. Since the virtual network gateway, it generally authenticate this communication. It doesn't require to be utilized here. There are other solutions we can use in place of this virtual network gateway, but here we want to just utilize this for routing this traffic for the sake of example. But otherwise we have other solution like virtual WAN and all, which I will be explaining in the next session. So what it will do, it will try to route the traffic to, it knows where this spoke VM1 exists, right? So so it will go to here, and since they already have a peering established, the traffic should be routed to this one. In case if you introduce a new VNet in future, right? So if there's a new VNet and you're going to connect, right? You just establish a peering this between these two VNets, and you create a route table, or create one route and associate that route here. You just need to let your VMs or traffic know, okay, if you want to reach to, let's say spoke VNet 3 or 4, that traffic should go to this gateway, and gateway has the information or has the routing information about the target VNet or destination. Okay, so that is what we are going to configure here. So with this, what we are eliminating it, right? If you want to communicate with the, let's say, spoke VNet 2, and if this need to talk to spoke VNet 1 as well, in future there is another one, and this one talk to another one, like you see, it's going to be clumsy, and eventually we'll see a lot of issues with the misroute configurations. So that's why we always go with this feature, hub and spoke model. So here you are introducing the virtual network gateway, and the virtual network gateway is a little bit of costly, and it also, if there are many requests coming, you need to look at the virtual network gateway SKU as well. You have to go for the another SKU where you get more bandwidth and throughput for your virtual network gateway. So to avoid these problems, Microsoft introduced the virtual WANs. We call it has a virtual hubs concept. So again, it's a similar concept, but instead of virtual network gateway, you are going to use the virtual WAN and virtual hub concept. And with that, you are going to avoid this bandwidth issues, or throughput issues, and you can also reduce the cost as well. So we'll try to explain that in the upcoming sessions, but in this session, I'm going to do this. So for now, what I've done is I've created a virtual network, and I've created a virtual network gateway. The deployment is in progress. So what I will do is I will go ahead and create these 2 VNets and 2 virtual machines. and we'll create a route tables and we'll create the routes. By the time our virtual network gateway will be created, then we will connect to one of the machine, let's say spoke VM2. Then from the spoke VM2, we'll try to connect to the spoke VM1. So here, if you understand correctly, so there is no direct connection between these two VNets. The connection is coming from this hub VNet, the virtual network gateways, routing the traffic or forwarding the traffic here. So while establishing the VNet peering between these spoke VNets and hub VNet, there are a couple of settings which you need to allow to establish this communication. So if I go back to this and the deployment should be in progress. Yeah, you can see here, it is still in progress. It will take some time. If I click on the operation details, you see just 6 minutes completed. So it may take up to 15 minutes more. So let me create our spoke VNet 1. So click on create. And let's create a new RG resource group. So I'm going to say spoke RG. And this is the spoke VNet 1. Okay, spoke VNet 1. Oh, something happened here. And let us choose a different location here. Let's say East-West location. And go to the IP address and configurations. I think it will be conflicting with the existing one. Let us choose the West Europe. So let us give the different address space. I'm going to give with the 192 series and create this virtual network. Similarly, let's create another VNet. And I'm going to say spoke VNet or spoke RG2. This is a VNet 2. So let us give a different address space here as well. So here I'm giving 172 series and creating the virtual network. So 3 virtual networks have a 3 different address space. Yeah, but they are in the same region, which is the West Europe location. So let me do a refresh here. I think this is still in progress. So gateway deployment also in progress. All right, so the three virtual networks are created. Yep, so 3 virtual networks are created. Let's go ahead and set up the virtual machines in each VNet. So I'll go to virtual machines option here, click on create Azure virtual machine. And I'm gonna choose the spoke RG2 for now. And I'm going to say spoke VM2 here, and it's West Europe location. I'm going to just create the standalone machines. I don't have any high availability solutions here. And let us choose the very minimal resources, let's say B1 series. This is to save the cost for the POC. And I'm choosing the spoke VNet 2 And public IP, for now, I'm just disabling the public IP address. I'll go with the default NSE rules and create the virtual machine. All right, so while this is happening, let's go ahead and create the another virtual machine. Click on Azure Virtual Machines, and we should be able to see the another now resource group. Let me just check whether it is created or not. So we deployed the Spoke VNet in the same resource group, so that's fine. Let's go ahead and create this one. Let us choose the hub RG here, and I'm going to say Spoke VM1. And let's create a new virtual machine here. I'm just proceeding with the default options here. So here I have to choose this Spoke VNet 1. Public IP I'm setting as none for now. We will enable it later. It looks like Spoke VM1 is created successfully, which is good. All right, so while these two virtual machines are in progress, the deployment is in progress, let's go ahead and create the route tables as per our plan of action. Let's create two route tables here. I'm going to search the route tables here. Click on create a route table. I'm going to choose hub RG. So this one I'm creating for the Spoke VM1. Ideally, I was supposed to deploy this in a separate resource group, Spoke RG, Spoke 1 RG, but I by mistakenly chosen the hub RG for VNet deployment. So I'm deploying the VM and all the resource in the same resource group, hub RG. So this is going to be, let's say, Spoke 1 route table. And let us enable this propagate the routes option or a feature. And let's create this. So route table creation won't take much time. I will go ahead and create the another route table as well, which is for the Spoke VNet 2. So I'm going to choose this Spoke RG2. And I'm going to say this is Spoke RT2. All right, so this is again starting the deployment. Going back to the route tables. Okay, guys, if you understand, just have a quick recap. So we have the hub VNet ready, and the hub VNet gateway deployment is in progress. We have the Spoke VNet 1, Spoke VNet 2 ready, and the virtual machines also ready. They are created successfully. We didn't see any problem. Now, the deployment with respect to the gateway is taking time. So meanwhile, I've started creating the route table for each network. So we will associate these route tables with the subnets of our virtual machine. And we will also create the routes, that we discussed. Based on this condition, we are going to create the routes. Okay, so the two route tables are created successfully. And if you look at our deployment, virtual network gateway deployment, that is still in progress. So I'm going to the first route table, spoke one route table. And if you go to the routes, this is where you are going to configure the routes. So as per our diagram, so if this one, right, I need to route the traffic. If any virtual machine from this VNet, if it needs to talk to this virtual machine, which is part of the spoke VNet 2, right, I have to route the traffic this way. So when you are creating the route table, you have to specify the name, spoke 1 to hub, or let's say spoke 1 to spoke 2 VNet. Okay, and through hub VNet. Okay, I'm just giving this name for us to easily understand. And what is the destination address prefix? So here the destination address prefix should be your spoke VNet IP address range. If I go back to this and do a refresh here, I have this spoke VNet 2 here, and click on this one, and you see the address space. So I'm going to specify the address space, which means any request coming from the spoke VNet, and it is trying to reach to this spoke VNet 2, and the request has to be routed to the virtual network gateway. So click on add here. So the virtual network gateway is already have a connectivity established. From here to this virtual network gateway, connectivity already established through a VNet peering. We are going to establish that peering as well soon. Here I'm going to add another route. Let me just copy here. Just to we'll modify the naming standard here. It's an opposite direction. It's like spoke VNet 2 to spoke VNet 1 through the hub VNet. So here I have to specify the VNet 1 address space. Any request from VNet 2 is reaching to this VNet 1 should be routed to the virtual network gateway. The gateway helps us to route the traffic to the destination. So the route tables are created and routes are defined. What I need to do is I have to associate these route tables to our virtual machine subnet. So each route table will have an option called subnet. There you have to associate this one. So here you have to specify to which VNet you have to associate, and within the VNet to which subnet you are going to associate. So I'm going to associate this for spoke VNet 1, and spoke VNet 1 have only one subnet. That's a default subnet. The name of the subnet is default. Okay, click OK here. Then I have to do the same thing for the another route table. I have to associate this route table with the our virtual network first, then to the subnet. So now what we have done is we have configured these route tables and we have defined the routes, and these route tables are associated with the subnets of your virtual machines. Okay, so almost all the setup completed. So what is pending is we have to establish a peering between these virtual machines. Okay, and once we establish a peering, we need something to test it. To test it, right, what I'm going to do is I'm going to connect to the spoke VM1 from my laptop. So I'm going to connect to this virtual machine, and since I don't have any VPN established, I am going to use the public IP of this virtual machine, and I'm going to allow 3389. So once I connect to this, I will try to do the testing between these two virtual networks. Okay, to do that, first of all, I have to allow the public IP on this virtual machine, and I'm going to virtual machine section now, going to the spoke VM1, And this one do not have the public IP address. Does it have the NSGs? It has the NSGs, but 3389 is not allowed. So I'm going to say allow 3389 port. Okay, and add this one. Then later, I'm going to enable public IP for this virtual machine. To enable public IP, and this for testing, in the enterprise, you will not have a public IP associated with your network interface card of your VM. Even if it is associated, probably it could be a mistake. So you can always, clarify with your, team leads. So I'm going to configuration, click on the IP configuration, and associate the public IP address. If you already have a public IP associated, you can choose it from the dropdown. For this example, I'm going to create a new public IP address. Click on save here. It takes few seconds to save the configuration and allocate the public IP for our virtual machine network interface card. So let's first create the public IP address. I will go ahead and select the public IPs here and click on create. So West Europe and resource group is same here. I'm going to say spoke VM1 public IP address. Okay. It's talking about the zone redundant. I don't think I need any zone, but let me check if my VM is deployed in any specific zone. I don't think this virtual machine is part of any availability zone, so it's not there. So IP address should not be in the zone then, right? So let's create this. All right, the public IP is created. Now let me see if I can associate this public IP. Okay, let me do a refresh here. Go into the virtual machine one and go to the networking and network interface card, IP configuration, and let me associate this here. I can see the public IP available here and click save. Finally, the virtual network gateway is created. If we look at this, do we have an option to check the time? Yeah, it took 36 minutes to deploy the virtual network gateway. So if I go to the virtual network gateway, it's up and running, which is good. So there's no status that says updating or provisioning, so which is good. Now we are ready with the entire setup. So if I just go back to the diagram, so we are done with all the configuration except this VNet pairing. Okay, let's go ahead and set up this VNet pairing now. To set up the VNet pairing, so we have to go to virtual networks. I have these two virtual networks. I'll go to the spoke VNet 1 and go to the pairings. Click on add pairing. Here I'm going to say spoke VNet 1 to hub VNet. Okay, that's a communication or pairing we are going to establish it. Okay, and here it's a reverse. It's a hub VNet to the spoke VNet 1. All right, so here let us choose this option. Here in the target VNet, I'm going to choose the hub VNet and select this option. So traffic to the remote virtual network, which is allowed. Traffic forward from the remote virtual network is also allowed. So virtual network gateway or route server, use this remote virtual network gateway or route server. You can use the, this option will actually ensure that the virtual network gateway, virtual VNet is, the traffic is reaching to the virtual network gateway. I'm going to add this. It's completed, and I'm going to do the same thing for the another VNet. Here it's a VNet. I would say spoke VNet 2 VHub VNet, right? And the same thing here. It's a reverse one. It will automatically establish it. So there should be a two-way peering that has to be established. And here I'm going to choose the same options. And click on add. All right, so peering is established. If I go to the VHub VNet, and you can see there are two virtual networks. The peering is established, and the status is connected. So the VHub can talk to these virtual networks, and they can talk to the VHub without any problem. And I'm expecting the traffic from VNet 1 to VNet 2 is gonna be established with the help of this Hub VNet and our virtual network gateway. To do this testing, as I mentioned, I'm going to connect to the spoke VM1 through a public IP address, which is already created. I'm going to take RDP to this machine first. Let me connect to the virtual machine. Then from this machine, I'm going to connect to the another machine, which is a spoke VM2 through its private IP address. Okay, it's taking some time to load. We are inside the spoke VM1. Let me go to command prompt. Since this machine configuration is very low, it's taking time to load. Let me say host name. You can see spoke VM1, that's VM name. We are trying to connect to the spoke VM2 and with the IP address. This is the IP address of the spoke VM2. You can see here, there's a private IP address, and I'm trying to connect now. So when you get this prompt, which means they can talk to each other, I'm going to connect with the credentials. Yeah, it's working. That's a good thing. So this is how you establish the connectivity between the multiple virtual networks without establishing VNet peering between them. So here in this example, we are establishing the peering with only one virtual network, which is the hub virtual networks, which is holding the virtual network gateway. In place of virtual network gateway, you can use the Azure firewall. You can also use your virtual appliances to route this traffic to the other virtual networks, right? So you can also use virtual WAN to implement such scenarios as well. So this is good. So we are able to implement this hub and spoke model in the Azure environment or enterprise cloud environment. You might see such use cases in your cloud environment. So whether it is a small environment or big environment, you will come across the VNet peering solution in the any organization, if you have multiple virtual networks, if they need to talk to each other. All right, so that's about the connectivity options within the Azure and between the multiple virtual networks. In the next video, I'm going to talk more about the connectivity through Azure Firewall, NAT rules, and how we can connect to your VMs through load balancer NAT rules. If possible, I will try to explain you how you can set up the virtual WANs and virtual hubs, and how you can have multiple virtual machines talk to each other using the virtual WANs. So that's the another topic. So this is all related to the virtual machines. If you have your virtual machine and you are under the networking section here, and your virtual machine have the network interface card, how the traffic is reaching to this NIC or your virtual machine, and different use cases. Right. Once we are done with the networking, then we will talk about the backups and other components. As a Azure admin, what you're going to perform, what other operations you're going to perform other than the networking, operation that we are learning today. All right. Thanks everybody for your time, and see you on the next session or next video.